Hello guys, welcome back to another video. So today in this video we will gonna see how to basically do a study or how to see the impact of the heat wave or high temperature onto the agriculture condition or any crop condition. So like this year, especially in the Indian region, in the northern part, the temperature was above normal during March, April and May month. So it has their own impact on the agriculture. So if you want to do a quick analysis or study how it is impacting, so you can do that analysis using satellite data such as Moody's. So both NDVI data is available through Moody's and also land surface temperature is available. So we can use both the things and we can see how high temperature we can compare very quickly with the past years. Okay, what is the situation in current year compared to last 2-3 years or any normal year, and what is the impact on the crop or agriculture. So if we can see the NDVI value, which is Normalized Difference Vegetation Index, which is basically an indicator of a health of a vegetation. So over the agriculture area we can see how NDVI value is varying during the high temperature. So we'll use Moody's data, 1 kilometer data for land surface temperature and 250 meter NDVI. So first we will go to dataset. You can do this analysis in Sentinel also, but I will be showing using Moody's. You can change that code using for the Sentinel also. So here if you go for Moody's, we just click here Moody's. So first of all we'll go for NDVI, then we'll go for LST. So here if you just search here NDVI, so this is the dataset. You click here Moody's 006. So I think this version has been superseded by this one, so we'll click on this one only and we'll just copy this. How to access? We will access this dataset. So you can see here all the band values. If I zoom it a bit, so these are the NDVI. Already they have computed the NDVI, so we have to scale it only. And if you can have surface reflectance bands also, you can compute through these bands also, but we will use directly NDVI. So directly, very quickly, we will simply write we create a collection. Like let me just write NDVI COL collection and simply will paste that collection. After that, what we have to do, we have to filter for our for what years we want data. So simply we will write filter, then we will write EE dot filter dot, or we'll put a or filter, and inside this we will write our dates, whatever dates we want. So we'll write 2-3 filters, EE dot filter dot date, and first we will go for, suppose we want to take 4 years, so 19, 20, 21, 22, 4 years we will take, because 19, 20 was normal temperature was there, and 21, 22 slightly above temperature was there. So we'll see, we will go for the wheat crop onto this northern region in the Punjab area. So generally the wheat crop, the highest NDVI will be during February month, and then it will, as crops start moving toward harvesting period, NDVI will decrease. So we'll take from 2019-0101 and we'll take up to May 2019-05-30. Then comma, and simply we will keep on copying this. Just we will change the year 2020, then again we will make it for 21-22. You can compare for n number of years. So now we have a data. After that also what we can do, you can select, or you can based on filter bounds also for your particular area of interest. So let me just filter bounds here. I have uploaded, either you can draw your area like this. There is one way you can draw this area, so it will come here. You can give filter bounds geometry, and you can select the particular band also if you want. So let me go for NDVI band only. So if I print this, NDVI collection, so it will give me the number of image collection. So here what I will do, I will just upload my shapefile, which I have already uploaded. You can upload your shapefile, area of interest from shapefile also. So what I will do, I will use India state, or let me just go for India district. This is the table. So what I will do, I'll just let me just go Punjab state. I will write table dot filter, and simply we will write ee dot filter dot eq, and we will just write the name of the state, and we'll see the column state name, so now we have filtered based on the Punjab state. So here we will write simple Punjab, and again I will run it. So 40 elements we are having, from including all the years. If you go here features, so you have image 19, this is 19, 20. So we have filtered for all these years. After that what we will do, like this NDVI, as I already told you, it is in this max this, so we have to scale it also. So what we will create a new function variable, you can give any variable, scale, let me just go for scaled, yeah, let me just give NDVI, and function, we'll write a function and here we will create one more variable, NDVI mod is equal to, so what we will do, we will scale it. So directly img dot select NDVI band, we will select, like here in the we have selected only NDVI. If you go for feature in the bands only, because we have clicked here select NDVI, otherwise if we don't write this, all the band will fetch. Select NDVI dot multiply, we will multiply with (0.0001). We will scale it. And also one more thing we can do, that I will show you later on. After that, here you can do the clip also. We will clip it, clip to Punjab. So we have done, and after that we will do, we will return img dot NDVI mod. We will return this image. So we will run this function to all the images inside the collection. Dot copy, we'll copy some properties also from the image, like these properties. We should, this index, if you want to filter further, so we have to copy this index also. And here we will just copy these 3 index. This is very important actually, to copy these, because we can access a particular data based on these dates. Then second time and and third, because we will create a graph also. Without these properties we will not be able to create the graph, so these we have to copy properties from there. So I think this is fine. Now this function is ready. After this we will put this function to, we'll create one more collection, NDVI COLL final, another collection we will create, and we will map simply this one will map on this one, function dot map, this function we will map, and again we will print. We'll see how it, this one we will print now. So on this collection we are mapping this function, so it will scale each and every image, and we'll run it. So now as you can see here, 40 images, features, only single band is there, NDVI double, okay, then it's fine. And properties, we have copied these properties, dates also, to access the data. And so now we can, what we can do after that, now we can create a graph kind of thing. Let me just show you. You can go to the docs. Here there is an option called UI and UI chart. What you can use, we can use this chart image, this one, and here series by year, this one. So we'll just copy this here, and we'll give our chart NDVI, let's simply copy this, and we'll keep on, we'll give all these, we have to pass all these parameters. Let me just enter it first, then we will give one by one. So now this is fine. Image collection, we have to give the collection. So what we will pass on, this final collection we will pass on here, this name. Then band name, we know this NDVI, you can check the band name from here. This is the band NDVI. Then region, for which region we want to do, so like Punjab, this is the Punjab. Region reducer, we want to take mean max, so we will take mean e dot reducer dot mean. Then scale is 250 meter data, this is the resolution, so we have 250 resolution data. Same day reducer, you can take mean also. If you have multiple basically observation during a particular day, then it will take mean. That here only one for particular day or particular fortnight, one data is there, so just you write mean here, no problem. Start day, end day is day of the year, so you can start from day 1, end day is 365. You can give anything, and just simply write print chart NDVI. So now if I run this, so it should be able to create a chart. Let me just switch off this. So it is generating the chart, as you can see. So yeah, I think it will take some problem. So what I will do here, Punjab dot geometry, I know what is the problem, dot bounds. So now I think it will create. So when there is a lot of vertices are there, so to make it just simplify a bit, so just write Punjab dot geometry bounds. So it will, because already we have clipped it, so now it has created. So for whole Punjab it has created, because we have taken the whole state, Punjab state, so it has created this. So as you can see, this NDVI 2019 18, this is the value of NDVI. It is in peak here, but it is when it is moving towards harvesting, the value is getting down. But in these 2 years, 21 22, as you can see, due to early maturity, due to high temperature, the NDVI value decreases early. And in 21 it has actually NDVI values are low in, I think this is 60, means around February, March. So it is drastically decreased NDVI value in different years. So like this, you can see, based on this, now we will correlate this thing with the temperature. So these two 1920 year was, I think, normal years, that's why, but these 2 years temperature was high. That we will see in the using land surface temperature. So similarly, also if you want to visualize the image, what we can do, we can add the image also from this collection. What we will do, we'll create one NDVI img. So you can what you can do, using through this collection, you can dot you can select, first you select ban NDVI, then after that, using this collection, which data you want to do, you want to see, you can, let me just go for this one, ban, this property now come in picture, 25.5 if I want to add. So what I will do, dot, after that you just pick filter, ee dot filter dot eq, and now you can give this system index. So that's why we have copied this property here, and comma, just give this. So let me just go for 2022 2022 02 let me just check any value for 2022. Okay, 63. Okay, this one I will take February data, 18/2. So I will just copy paste this here, value here. Okay, now fine. So now we have this image. After that, simply we will map dot add layer, and we will just write this image, NDVI image, and then we have to give some colors to it also. So what I have done, I have already created one palette. Let me just copy that palette. This is the NDVI palette I have created. Different colors I have given already. Let me just define something, NDVI palette here. So I'll just write comma palette. I will write simply NDVI palette, and we have to give minimum maximum value also. So I will take minimum value 0 NDVI, maximum value 1, and after that I will give name NDVI underscore 18022022. Like this you can add. So if I run this code also, so I should be able to add NDVI here. Like this you can add multiple layers, like you can see here, this is the NDVI image. NDVI image is coming here. So like this you can add for multiple layers. Just you have to like this, you have to, what you have to do, just copy this, again paste, and you can go map add layer and just select that. So you can do for multiple. So suppose I go for March, because we want to see the difference in March or April image. Suppose 6.3, or after that this one 22.3. I will take this one image, I will take this, and let me just go for NDVI image 1 here, and simply I will write 2020. I will take 2020 image and I will just change it 23. And simply I will NDVI image 1, and this is 2023. So now we will be having two images, one for 2020, 22. So you can compare the NDVI values also. So I think there is no image. Let me just check for 2020. What is the image? Date. I think we are missing the date. 21/3/2020. After this one. Yes, this is one. This is 21. It should be 21. So I have to change it to 21. Now if I run this, we should get 2 images. Now you can see here, this is the 22 image, this is 2020. So you can see here the 2020 images much darker, much greener is there. So it has shown, that's why you can see this difference also. The 2020 is having higher values less than this, that's why. So like this you can change the images. You can see the images. You can see for 6 and this should be 0.5. So in this also there will be difference. As you can see, the 2021 is much more greener than the 2022, as you can see here, like this. So there is a differences there in the NDVI, maybe due to the high temperature. Simply you can go for 2021 also. Now okay, we are done with this NDVI kind of thing here. So now we will go for the land surface temperature data. So similarly what we will do, we will simply copy this collection again, because we want exactly same dates. Instead of this we will take land surface temperature LST. So we'll check the data of LST here. Mode is so land surface temperature is there. Okay, daily, we don't want daily. Let me go for another 8 day. 8 day is fine, I think. So we can take this data. Okay, this is our supersede. By the way, click here. Simply we will copy this here and we will replace this with this. All the things we will let remain same. So like we are taking average of whole Punjab. You can go for particular district also. That you have to change here district. That I will show you how to just very quickly you can change. First let me go for this. So now if we print this LST collection also, just run this. So you will have double L. Okay, so you will have collection of land surface temperature here. Okay, let me do okay, this NDVI we have to change. We have to give the band name LST. You can take day also and you can take night also. We will take day because band name is different. Now if we'll print, we will get the land surface temperature also. Yeah, this is the collection. So many elements are there. Now similarly again, because we want to convert into the Kelvin, this is in Kelvin, we have to convert it to the degrees. So we will create another function. Let me just copy, we'll write one more function, variable LST degree COLL function. We will pass img image and this and then we will write here LST degree, sorry, LST degree is equal to img dot select. We will select the band. We want to keep it okay. Let me just how to Okay, multiply. Oh, we have to see the scaling also. This scaling is 002 and we have to subtract by 273 dot, simple as that. We will do multiply and we will clip after that with our area of interest. So either you can draw, we are taking this Punjab directly. So now we have multiplied by 0.02 because this is the scale factor, and then to convert to degrees we will do like this. After that we will return the image, return LST DEG degree. We will return the image, simply we will copy the properties, similar properties we will copy like this. Dot this one, we will copy the same property. This is fine now. Now again we will print this ST degree collection. Now we will see another collection should come. Okay, we have not run the function now. We have to create one more, LST COLL final is equal to collection dot map, and we will map this function. Sorry, this collection dot map now we will run this. So yeah, 76 is there, features are there, so it is in bands and properties are also there. This is fine. Now we have converted to the degree also. So now again we will prepare a chart like this, simple chart again, and here just we will write chart LST, and here also I will write LST, and in the collection I will just write this LST collection final, and band name we will change this band name, and geometry this is fine. I think Punjab we will reducer is this, and this we have to change 1 because this data is 1 kilometer, and we will run it now. So now we should be able to see two graphs, one for NDVI, another for, this is for NDVI. Let me just open this and LST. Okay, here we have to write again that geometry dot POUNDS. Okay, it has worked without this also, no problem. So this is the LST. As you can see now, land surface temperature up to this 60th day, day 1 to 60th day, these 2 years 1920 it was fine, 20 is like this. So in 2022 the temperature was down, but suddenly after 60th day you can see the land surface temperature of 2022 is much higher, and even for 2021 is higher, and 19 and 20 it was lower. So in year 2022 land surface temperature is going higher. So like this you can compare the data, and similarly in the case of NDVI it is just opposite, temperature is higher so NDVI is decreasing. So early maturity of crop is happening, NDVI value, so you can correlate this thing. So now we have this chart also. Now we can add the image also. As we have added that image, we can like this, we can create, we can add the images. Before chart, what we will do here, I will just write LST and LST collection final, select this band just we have to change the date. Let us run. Okay, we have to map.add layer also we have to do. Like this, we will map.add layer we will do similarly. Just copy paste this, and minimum maximum. Okay, let me just take this value from here directly. So this is the whole thing, this is the whole visualization parameters for giving the colors. I will just write this visualization here, and I will replace this whole thing with VIZ directly, and I will just change the name LST. Like this, image 1. So this is the minimum maximum value, everything is there. So if I run this, there is some error, I think. Image 1 not found. Okay, here. So you can see the LST images of 2 years. This is for 21 and 2020 it is not there. I think we have to change this day. Okay, now 2020 is also. So as you can see, 21 it's a bit higher than 2020. So if we will change the this date also, suppose if I take this date 73 1. So let me just see the inside the collection 76 around this one. Okay, so if I take April data 7/4/2022, it should be 6 or something. I will change it later. It should be 8 for 2020, I think, because leap year is has one extra day in February. Okay, we have to change 8 here also. 2020. So now we have, okay, 2026 data 6 is there. Okay, it's fine. So now you can see the land surface temperature also, how it is different. Into 7 it is in 2020, so you can see more reddish color is there, and if you go, this is much more greener. So if you go for inspector here, so you can see all the NDVI values also. So NDVI in 2021 it was 812, 2020 8.85. temperature significant difference is there, LST 27. So like this you can see the difference. Okay, let me just go for 2020 only here, 2022. So if you put inspector somewhere here, So you can see, okay, NDVI image not much difference is there. 2022, let me just give it 2022, but in this difference is there in LST, 30 degree and 40 degree. So you can see the difference is in LST, how much significant difference is there. Here if you click here, so you see 2020 is much more, temperature is very less, is very much lower than compared to 2022. You see this, and in case of NDVI, 2020 is much more greener, 0.81, 0.5. So NDVI is lower in 2022 and temperature is higher. So this you can visually also compare, and you can see this value. So further, what in this chart, what you can do, you can download CSV file for this, and you can download CSV file for this, both the things. And if you go in downloads, you can open this CSV file. So now you can see this is for, I think NDVI is every 16 day we have, and this is temperature we have every 16 day we have NDVI and LST every 8 day. So let me just copy this NDVI values here. So what we can do, we can delete in between 8 days this one, alternate we can delete, so that we can compare the values. So now you can see these values. This is for LST, this is for NDVI. So if you go for this, okay, January, February, so if you go for March and April, these four, you can see the temperature is higher in these two, like 37, 40, 42, 30, 35, 37. So in these 1920 temperature is lower, but here it is higher. But if you see here, NDVI will be on the lower side. As you can see, 0.43, but here it is 0.3. So NDVI is lower in these 2 years, whereas temperature is higher, 30, 35, 37. So you can see the difference here. You can play with these statistics. And for like January, if you see, temperatures are much more basically similar, 16, 16, 16, 16, even 22, it was much lower here for January and February, as you can see. So NDVI values also not different. It is 7, 7, in the range of 7 everywhere, you can see. But suddenly from March and April, in these two, you can see temperature is 21, 21 in these 2 years, 24, 24. So you can see here the NDVI values are 0.7, 0.7, but here it is lower in 21. And further, specifically in March 2nd fortnight and April, you can see it is on the range of points above 0.6 and 0.65, but NDVI values are 0.5. So it is NDVI. This is about the whole state, as you can see. If we if you go for a particular district, so simply what you have to do here, simply let me just go for any district name, very small area I will go for. But in the district I will go for, and I will just run this. So it will just do all these analysis for particular district only. So if you go for the specific district, actually for the whole state the values are averaging out, but if you go for particular district like this particular district, so you will be able to see the much more difference. Like here you can see the NDVI difference. If you see visually also 6.3 and 5, see you can see the difference of values, how NDVI values are different. And even for LST you can see for April and for 2022 it is major differences there. So you just make it like this, and for LST also. So for this particular district you can see LST difference, and here you can see the NDVI difference. These 1819 are going perfectly fine, but 2021 NDVI values are lower. So now if you download CSV for this file and for this, so you will be able to see the much more difference. Okay, this is for NDVI and this is for LST. So what I will do, I will just copy again this here, these values. Just let me zoom it a bit. I will again remove this alternate because we want to compare only the same because this is 16 day, this is 8 day. So now you see this during January temperature are not that much, even lower in 2022. So you can see the NDVI values also range of similar 7, 6, 9. It is better even in 1920 so it is much better. And this then February also, if you go, temperature are lower compared to other years, so NDVI values are also fine, there is a 0.78. But if we enter in March and April, so basically from March 2nd fortnight, here you can see this difference here, like it is the order of 0.4, but here it is 0.2 in these 2 years. So for this you can see for April. So basically crop matured quite early, as you can see here in these 2 years NDVI values are lower, but this LST is higher. So here you can see the difference in the basically in the April this is April month. You can see the temperature is higher, 29, 39, you can see 36. So NDVI values range of 0.4, but here 0.2, so it's drastically decreased NDVI. So this is maybe due to the early senescence of the image, early maturity of the image. So after that, okay, this is image is moved to the harvesting stage, that's why. So this is the two major, you can see here 0.6, 0.5. So it's a major difference is there here. So like this you can do the analysis for any other any district. Just change the name, go for Mansa. So now for this is for simple Mansa district, it has done the analysis. So like this you can simply change the area of interest very quickly, it will change everything. Like NDVI also it is different, so you can see the similar pattern in case of Mansa district also. In 21 it is much lower, and also for LST you can see LST is higher. So district by district you can change and you can do the analysis. State name, you can go for another whole state also. Suppose I go for Haryana, so it will run for full Haryana. Like this, it is created for Haryana. So like this you can change the whole state or district. So here also you can see similar pattern, kind of pattern in Haryana state also. You can see how LST it is 2022 it is very high compared to 2020. So major difference is there in case of Haryana also, and similar pattern in NDVI. You can see how drastic difference is there 21-22, and this is for 18-19. So crop has matured, like here values are similar, but after this it has gone down drastically. Similarly for this also LST is higher, so you can download these CSV files from here and you can compare these values. And now if you want to do for district by district at a go, you want to do what you can do here. Let me just go for Punjab only. So suppose you want to generate the statistics for district by district for whole state. So further what you can do, like we have created this, we have created this collection, NDVI collection final, which we have created. After that we can simply do where NDVI bands, you give any image name and NDVI final, so it will convert it into the bands, basically from collection to image. If you write this function, so it will convert. After that we can run the zonal statistics onto that, and similarly we'll do for the this also. Here we'll write LST bands and LST final, 2 bands simply. So we are converting, so it will create this image with all the bands in a single image, and we can run the zonal statistics onto that. After that we will write a simple code for zonal stat also here, where NDVI stats is equal to, we'll write this image name dot reduce regions then bracket, curly bracket, then we'll write collection. Collection is basically you have to give the shapefile or your for which you want to generate the statistics. So just write Punjab. This we are writing collection here. Then after that you have to give scale also, and you have to give reducer. You want mean or what? So simply e dot reducer dot mean I will write like this, and scale is, this is 250 meter, you have to write a scale simply. So now this is NDVI stats. Similarly you can generate this for this. After that we can write LST stats, we'll write LST bands, and reduce is fine, this is 1000. So this is now we can export it to the table as a CSV. We'll use this code for exporting it, simple. After that we can write here export to table, and you can give description to anything, otherwise NDVI stats, you can give any name, and after that you can just NDVI stats, give this name. This star is basically it will not write the geometry values, polygon coordinates kind of thing, otherwise that column will be very long. So simply we'll export, use this, and after that we'll similarly export to drive in case of here also LST also. And instead of this we will write LST stats. Now it will create the mean value for all the polygons. And if I run this, so if I run this now, so you'll see in the task you will have 2 things. NDVI stats, you just run it, you save it, and for LST stats also you just run it. So it will download the, it will create the statistics district wise, and it will save in the Earth Engine, oh sorry, your Google Drive. So it will take I think couple of minutes to download this. You can do, and one more thing you can do, we have not given any agriculture mask, so what we can do, we can use here, we have ESA LULC Earth Engine. So we have to do the agriculture mask also, because we want to do for agriculture mask, so you can use that also. So we will use that agriculture mask also here. So what we will do, we will simply use this one in our code. It's very what we will do, somewhere here we will write this code where LULC is equal to, this is the ESA dot FIRST. We'll convert this collection to the to the image. Now the 40 class is for agriculture. I know if you see this one here, the 40 class is cropland. So I will very quickly in this function only, what I will do, simple write update mask like this, LULC dot equal to 40. So simply I will write similarly in case of LST also in this function. Where is my LST? Yeah, here, I think here I will write dot. So now if I run this, so this is downloaded again. If I run this, okay, double dot is there, so I will remove one. If you run this, so now let me just go for the drive first. Let me change my account. So as you can see, okay, there is some error. Let me just go for, okay, this location load image collection asset not found. Let me, where I have copied from, this is the one. Okay, version 100 I have to write. Okay, there is some error. This should be 100. Then I will run this again. So now we should be able to get the agriculture masked these values. So as you can see now, if you zoom into an area, so this areas, urban areas and this forest area have been masked. Only we have agriculture area. As you can see, this it has masked this urban areas or all this. So now where statistics are based on only agriculture part. So in the my drive, what I will do, I will just remove this and I will again download this, because now this will be based on my agriculture area. So at one go you have LST data for 4 years, agriculture masked, you have NDVI data, and then you can do the analysis. You can compare the data set and you can see the effect of the high temperature over the years and how it has impacted the NDVI values. So if you have your particular crop mask, you can upload your mask in the asset, then you can use that mask. So as you can visually also you can see here, NDVI values are lower in the case of 2022 compared to 2020 and LST is higher. So now you can see here in my drive, I think NDVI stat has been downloaded. You can right click here on the drive and you can simply download it from here. Download. So here this is the LST stats. So what I will do, I will save this code first, because save as, and I will give any name, NDVI underscore LST analyses. So like this you can save. I have saved this, so you can only change this filter bounds. You can change this area or you can change this year according to you, dates according to you, and you can run this code, so it will run. Let me just show you how the image. So as you can see, it has calculated the statistics for 29/1 like this. You can see 9, all the statistics it has computed, and you have this Punjab state like this, and I think this is district name. So like this you can, it has generated the statistics. Now you can compare the statistics, you can do the analysis using these statistics outside. So you can remove these columns which are of no use, and similarly for NDVI also, this is the statistics. So like this you can do the you can compute the statistics and you can do the analysis outside of the Google Earth Engine also. So I will share the link of this code, so you can change it according to your need, and you can add so many things. So you can create more graphs, because this is especially for the wheat crop or in northern region of the India. So this is for that only. So you can change this area of interest and everything according to your need. So that's it guys from this video. I hope you liked the video, and please give a thumbs up to the video and do subscribe to the channel.